Hello, geometry. Welcome to lesson 12.2 on conditional probability. So the state test also loves conditional probability, right? Conditional probability is going to involve two-way tables, as you see. And my one thing about conditional probability is that instead of finding the straight probability, right, looking at the entire sample space, conditional probability limits the total. That's my biggest takeaway. Limits the total. So in a problem, before you look at the probability of an event, they give you something else first. So you can cut your sample space not in half, but you can kind of separate it, right? So again, just think of it, limits the total as we go through today. All right, great. All right, example 1. It says, understand conditional probability. A student committee is being formed to decide how after-school activities will be funded. The committee members are selected at random from current club members. The frequency table shows the current club membership data. So this is what I call a two-way frequency table, right? Because it goes two ways. It goes horizontally. So these are your grade. And then it goes vertically. Not this last. This last is the total column. So it goes vertically. And these are the clubs that they're involved in, right? The club. Okay? So each cell represents an and situation. So this 3 are sophomores and in drama, right? Sophomores and drama. This 36 is the total of sophomores. This 17 is the total of drama. And this 115 is the grand total, right? This is the total, the grand total. So it says, what is the probability that a member of the art club selected at random is a junior? So this is the problem that we're doing. So what they're telling you is that this person is a member of the art. This is given to you. We know that that is true, given. This is when you use conditional probability. So we are looking for the probability that an event B will occur given that another event A has already occurred. Given that A has already occurred. Probability of B given A has occurred. This is called conditional probability. It is written like this. Probability of B given A. All right. So we are going to just look at the frequency table. Okay. So we're going to use the frequency table. This is the method I would use. We'll also do a method 2, but this is the method that I would use for sure. So I want to find the probability of B given A. All right. So in this case, right, let's use our letters. Probability of being a junior, given that they're in the art club. Right? So we're looking at just the art club members. So I'm going to focus just on this column alone and this bottom total. That is my bottom number, 58. And out of those 58, how many are juniors? So now that's where I come across where the juniors are, and I find that number in my highlighted column or row. So again, art is the highlighted column, 16 is the number in the row. This is my conditional probability, 16 out of 58, 0.276 or 27.6%. Notice I did not use the grand total, not the grand total. And again, this is what I was saying about limiting the total. You're not looking at everybody. You're looking at a certain group of the sample space, the population. All right, sweet. Okay, now let's look at this same exact question from a different perspective with method 2. So method 2, same exact problem. Method 2 is going to utilize what are called the probabilities. Okay, so there is a formula for conditional probability. The probability of B given A is the probability of B and A divided by the probability of A. I think of this given as a fraction bar, right? So think of that as a fraction bar. So this fraction bar is this fraction bar. So it's the overlap over the given event. So to use this, right, the probability of J given A, I would look for the probability of A and J over the probability of just A. So to find the probability of A and J, I'll do the top in blue. To find A and J, I'm looking for where A and J overlap. A, J. A and J overlap here at 16. So I would do 16 out of everybody. And then to find the probability of just A, I would use the total of A, 58, out of the grand total again, 58 out of 115. But again, if you were to actually multiply these out, you would do 16 over 115 multiplied by the reciprocal, and these 115s would cancel, and you still arrive at 16 out of 58. So again, I'm in a sense using this formula and the probabilities when I just use the frequency table that we did in the last slide. And again, you still get 0.276, right? 276, which is still 27.6%. And there you go. Conditional probability, very, very, very important. They do not give you this formula in state test. It would be nice if they did. All right, so let's take a look at the next slide and formally introduce conditional probabilities. Oh, false. I'm going to stop the video there. I apologize. So that was our introduction to conditional probability. The last video is going to be kind of heavy because it's going to involve more formulas and more problems. But conditional probability, very important to understand the basic formula.